Okay, and welcome back. This is Beaches or Shorelines 2. We're going to talk about beaches today. We talked a little bit about beach processes with longshore current. Now we're going to actually see what waves and beaches do to, or waves and longshore do to beaches in terms of erosional and depositional type shorelines. If you take a look at erosional, it looks like the marine environment is actually cutting back into the geologic environment. So we're actually getting cliffs and stacks and caves and arches and tombolas, and we're getting former cliffs where we used to have a higher sea level or where land arose. We have wave cut terraces at different levels. Then we have depositional, where it actually looks like water has gone over onto land, and we have relatively nice sandy beaches. We have lagoons. We have barrier islands. We have sand spits and bay mouth bars and things like that. Okay, erosional type beaches. Here we actually have headlands. It's more of a cliff type environment. We have sea arches where as the headland gets thinner and thinner, these caves go from one side to the other and make arches, and we actually have stacks where the arches have broken. We have stumps out there where the stacks have actually been cut back. We have wave cut platforms, cliffs. We have another one down here if the sea, during low tide or if sea level were to rise, or excuse me, fall. These are usually tectonically active. They're called continental or active continental margins on the west coast of the United States. And I'm not going to show you this shock wave because I showed it to you last time where the waves motion is actually creating a longshore current and turns headlands into bays, erodes the rock here, turns it, puts it into the bay. So we have erosional and depositional environments, and then eventually flattens out and straightens the beach. Depositional type shores actually show you sediments. Where we have really close to the shore, including the shore, we have sand. And then as we go out, the particles get smaller and smaller because the energy in the water gets smaller. And then finally, the shale where silt falls down. And then when all the particles go out, we start getting calcium carbonate coming from sea creatures collecting down on the ground. So we have limestone facies, shale facies, and sandstone facies. If the sea level was to rise, we'd actually find out that the sandstone actually moves farther inland. Shale would move on top of it. Limestone would move on top of the shale and eventually over the top of the shale and the sandstone. Or if we actually get the land to rise or sea level to fall, we'd find the sandstone move over on top of the shale, shale on top of the limestone, and eventually the sandstone on top of the shale on top of the limestone. This is a cutaway view of the Grand Canyon, and you can actually look way down here and see that there are sandstones and shales and limestones, and this limestone was in this environment when it formed, so it was well underneath the water. And then we actually do have some other sandstones in there where it was actually shallow water, and we have shales in there where it was intermediate water. These are typically not tectonically active, and this would be a passive continental margin like the east coast of the United States, where that one is going to be more like the west coast of the United States. Here's a picture of the Grand Canyon with sandstones and shales and limestones, and you can take a look at it and you can see it was actually really high, but even this sandstone way up here at the top was underneath water at some point. And we think that there's actually quite a few miles of material that's been eroded away, all by water. And this is the Colorado River, where you can see this you can basically see that you only get plant life, and I forgot what that was called. It's not reptilian. It's close to that, but you actually get this life where there is water, even in a desert environment where you'd find very little life up on top. And here's a path where you can walk down into the canyon. It's about 1,000 feet on one side, and it's about 1,500 feet on the other side. But you can walk down into the canyon. They've got a campground down there. They actually have a cabin down there at some point, and you can see that there are flat areas that you can go down. You can also raft this river, although it gets white water in quite a few places. Depositional features, we get spits. Waves are coming in this way, so longshore current is moving sand along the beach this direction. If it reaches a deeper area, the waves lose energy, the sand drops, it starts filling in the area, more sand comes in, pretty soon it's up at the top, and it starts moving across this bay, and if it goes to the other side, we'll actually call it a bay barrier or a bay mouth bar. You can see there's a spit on the other direction. Tombolo forms when you get a sea stack and waves come in and they actually bend the sand around, and I showed a picture of that back when we talked about waves. And you can also get barrier islands, which help protect the land mass itself. Barrier islands look like this if you've ever been to OBX, the Outer Banks. This is sort of a backward picture of it, or it's actually looking to the north, but we actually have a sand beach on the ocean side. We have a dune, we have a barrier flat, we have a high elevation sea marsh, 20 or 30 feet off the ground, a low elevation, 5 or 6 feet off the ground. We have another sort of low area, and then we have a lagoon. And if these things actually, you get a sea rise level rising, it actually pushes these things landward, and you can tell that because the lagoon side actually is where the vegetation is, and it makes peat down here in this water, and as this barrier island progresses over, the peat looks like it moves over and it pops out the ocean side, and you can see here's the first peat. Original, as it moves landward, peat moves farther, and eventually it moves all the way across like you'd expect to see at OBX. Deltas, this actually happens at a river carrying lots of sediment, hits a relatively large continental shelf and deposits the material. This is the Nile River Valley delta, and this is arctate type delta that has this arch shape in the Mediterranean Sea. So river deposits in the coast, they're fluvial, which is river. It's river influence, not the marine influence. You have Bird's Foot Delta, which I'll show you in the next picture. If it's more ocean influence, like there's more waves and things, you get this arc shaped. Here's a bird foot. This is the Mississippi River delta, and as it moves over you can see it branches off and it zigs and zags. Here's part of it, there's part of it. It used to be over here, used to be over there. As it fills in this area, it'll get too high and it'll actually break off someplace else. There's Louisiana, actually New Orleans, and that's Louisiana. That's the lake that actually caused a lot of problem for a lot of Louisiana, or a lot of New Orleans, when the Hurricane Katrina came through. We have a shepherd classification of coasts, and it's actually a primary and secondary coast. Primaries are more geologic, they're more youthful, they're actually more geologic. You can see that there's ice in the background, so it's scouring more down into the bedrock. Drowned river valleys, because of glaciers, volcanic coasts that were actually tectonically active, where we have mountain building, and there's actually another cliff retreat which I showed you before. Secondary coasts are not so much geologic, they're more marine controlled, and they're tectonically passive, and examples of that are going to be coasts that were straightened. There's no more headlands or bays. Coral reefs that form out here, showing you that the water is relatively clear. Salt marshes, marsh grasses, these are trees, mangrove trees, and they actually spread out, getting air for their roots, but they'll actually spread out holding sediment, and they'll make the land grow into the water. Emergent coasts. Emergent coast is anything where the land actually rises or the sea level falls. This flat area up here was where the water was. It's called a wave cut terrace or wave cut. This is an upward motion of land or a sea level drop. Once marine, now land. You get these wave cut terraces, you get stranded beach deposits up here, where the water comes in, cuts out this flat area, and then as the water drops down, this will actually make another wave cut, and you can see it actually keeps cutting into the coastline, moving farther and farther and farther in. And you have submergent coasts where actually the land goes down or the water comes up. Once land is shallower, now it's underwater, drowned beach deposits. Here's a start view. This is an emergent beach where you actually get the land, the stuff that was underneath the water now above water, so we get wave cut platforms and things. And this is a submergent coastline, where we actually start getting things that were up above water, like this sandbar, now below the sandbar. And I think that's the last one we're going to do today. Okay, thanks for stopping by. Appreciate it.